All right, let's go ahead and get started. In the last few minutes, I changed some due dates on things. I had a lot of people ask me for an extension on the 7.1 web work, and I'm not available very much on Monday, so I pushed it to Tuesday night. If you have questions, yeah, please keep the discussion board in mind, and yeah, I'll try to answer there. But unfortunately, I'm not really all that available on Mondays. Also pushed out the written homework by, I think, a day. So I think we did one of these washer method examples, right? Okay, so we talked a little bit about the way this works, but just to kind of recap, so we talked about two methods really, the disk method and the washer method. What's the difference between those two? Or are they different? The washer has a hole in the middle. Is that it? So really the things we're finding volumes of, so let me write down what we talked about for the disk method. It's the integral from a to b of pi times whatever the function is squared dx. So that's the disk method. We talk about what the washer method looks like? It's a little bit different. Yeah, basically it's two of the basically I'm finding the difference between these. So I think the way I wrote it down was big R squared minus little r squared. Where these big R and little r, those are like the larger and the smaller radii, or the outer and the inner radii. Because basically this little rectangle that I drew here, the way that we find these volumes, like everything we've talked about so far, is we're finding the volume of cylinders. The only way to find the volume of a cylinder is to find the volume of a cylinder with another cylinder punched out of the middle of it, is to first find the volume of the larger cylinder. So this is my outer radius. Then find the volume of the smaller cylinder given by my inner radius, and then find the difference between them. But in essence, I'm doing the disk method twice. Basically, I'm finding the volume of two different disks and finding the difference between them. We feeling good about that so far? Good-ish. So let's look at the same area, but now I want to revolve this around a different line. So I had a couple people ask me about the written homework. There was a question that involved this, which I haven't really talked about yet. So everything we've talked about so far, we've either revolved around one or two lines, either the x-axis, the y-axis. Now we're going to talk about what happens when we revolve around different places. So I'm going to draw this area again. It should be identical to what I did for you last time. So x cubed, x. Here's the area I want to make a volume out of. But now, where am I going to revolve this thing around? This is not going to be to scale. I made my graph too large, but I want to revolve around this line up here. So let's talk about what makes that different. I think the one we did right at the end of class last time was we revolved that same area around the x-axis, right? So we're still revolving around a horizontal line, but now that horizontal line is raised. So let me draw a rectangle that kind of describes the cylinders I want to make here. So based on the way this rectangle looks and where the line of rotation is, am I looking at disks or am I looking at washers? There could be washers, right? Because that rectangle does not reach the axis of rotation, does not reach the line that I'm going to revolve it around. So I'm going to have something hollow. So I'm going to set up the washer method. The volume is equal to the integral from A to B. By the way, I totally glossed over this, but I drew a dx rectangle. Is that appropriate for the line that I want to rotate this over? Okay, so that's going to make a disk. That's not going to make a, well, we haven't really talked about what the alternative is, but if I want to revolve around a horizontal line, I need to be setting this up in terms of x, which I'm about to do. So talk about the outer radius squared, the inner radius squared dx. So now let's talk about those things. For the inner or the outer radius, first of all, what function is going to give me my outer radius? Is it going to be the straight line or is it going to be the curve? Why is it the curve? Why is it the curve and not the straight line?
Because in this case, we're rotating it above the line that's above it,
Right.
or around the line that's above it.
Okay.
Y equals 2.
So yeah, we're rotating around y equals 2. So why does that mean the curve is the outer radius?
The furthest away from
That's
y equals
exactly it. It's whatever's further away from the line I'm rotating around. If I were to make that solid, the outer radius is going to come from the thing that's further away from the center. So our outer radius is going to come from y equals x cubed. So everything we've done before this example, we have either gone around the x-axis or we've gone around the y-axis. So we've really just been able to write down what the function is for the radius. I don't think we can do that anymore though. So now I really want to know how far is this out, how far is the curve away from y equals 2? How would I find that difference? The curve minus the y value, right? So I can call this x cubed minus 2. Will that give me the difference between those two things?
It should be the other way around.
Would it be the other way around? I don't know. First of all, it doesn't matter.
Yes.
You think it matters. Why? Maybe. It's backing off of yes.
I think it matters because if you subtract 2 from y equals x minus 3, you're finding the distance from the bottom of that bottom curve line down to,
Okay.
which would look different than the distance from x minus 3 up to the 2 line.
Okay. So they might be different in that regard. Let me ask this question. Now that I have this outer radius, I have two options for it, right? X cubed minus 2 and 2 minus x cubed. What am I going to do with those? I'm going to square them. So I don't think it does. I don't think it matters all that much. So the fact that we're squaring in this case means we're going to get rid of whatever ambiguity happens here. But I will say this, I'm going to leave x cubed minus 2. Basically, I can't go back to previous slides because I didn't use the slides last time, but let's say we were rotating around the x-axis. Essentially, that'd be like calling it x cubed minus 0, right? Because if we were rotating around the x-axis, that would be y equals 0. So I'm going to, just for consistency, I'm going to adopt putting whatever the variable function is first. But yeah, I think to compare it to the line y equals 2, I think this is a good outer radius. Questions on how we define that? What's a good corresponding inner radius then? Is it as simple as x minus 2? How come?
I don't know if it is that simple, but it follows logically.
Okay. Well, why'd you say x minus 2?
Because we'd be taking out the distance from the X line to the 2 line.
Right. So basically, I'm trying to find this distance here. So let me label some of these things. This right here is my inner radius. And this right here is my outer radius. So when I'm finding the heights of these rectangles, these rectangles have vertical height. So to find the heights of them, I need to compare, or I guess I'm not talking about the height of the rectangle, I'm talking about the radius that it's going to make when I wrap it around the line of rotation. How do I find this value little r? Well, I'm going to subtract whatever this y value is down here. That's going to be y equals x. Subtract that from this other line, which is y equals 2. So I'm okay with both of these radii, x cubed minus 2 and x minus 2. Questions on where those came from? If we're okay with that, we finish setting up the integral next. One thing we haven't talked about yet is the bounds. What do we think they should be? 0 to 1. Yeah, going from the origin to this crossing point here, which I think we said last time was 1, 1. We didn't say it, we're saying it now. So pi times the integral from 0 to 1 of what? X cubed minus 2 squared minus x minus 2 squared. Is this an integral we can do? It is, and we're going to have to do some algebra to make it a little more digestible. But what is x cubed minus 2 squared? That should be x to the 6th minus, not 2, minus 4x cubed plus 4 minus x squared plus 4x plus 4 dx, I believe.
But the 4 canceled out.
The 4?
Because the distributive.
Yeah, they should. So x minus 2 squared should be x squared minus 4x plus 4, and then I negate them all. Okay. So yeah, I agree the constant 4 should go away. Now I think this integral is doable. So it should be pi times a bunch of terms. 1/7 x to the 7th minus x to the 4th minus 1/3 x cubed plus 2x squared from 0 to 1. Whatever 2/3 plus a 7th is. All right, I kind of charged the end here, and I would not be shocked if there's errors in here, but now let's talk about it. So any questions here? So the big chief difference here is that instead of rotating around one of the coordinate axes, we're rotating around some other horizontal line. What did that change? The fact that we rotated around y equals 2, what did that change about this process? Or about the way we had to define things? Or did it change anything? How so?
By subtracting.
Right, so we have to account for the fact that the radius is not just equivalent to the function anymore. So we had to subtract 2 off of both of them. But from there, I think the way you handle the integral should be pretty much identical. Once you have those radii defined, then you can go attack the integral the way we have been doing. Questions here? Okay, so let's stick with this area, and now we'll rotate it around x equals 1. So I am looking at the same exact two-dimensional area, same region, same location, but now I'm going to get a different volume because I'm going to rotate it around a different line. So now let's talk about what things have to change here. How should we start setting this up?
Change it to y,
Why do we know we have to change this to functions of y?
because our radius is gonna be going towards x equals 1, the x equals 1 line.
Okay,
Oh,
okay. So yeah, we're rotating around x equals 1. And from that, you think we have to now, instead of defining this rectangle, or sorry, defining this integral in terms of x, now we have to define it in terms of y. Does that make sense? If I rotate this rectangle I just made around the x-axis, what's that going to make? It'll make not technically a cylinder. It'll be hollow, right? But it's going to be this, except for that hole punch in the middle, this is going to be a solid disc. And I think I tried to do this counter example on the chalkboard, but I'll try it again here. Let's say we did do a dx rectangle, so it had this vertical height to it. If I revolve that around the axis we're trying to rotate over, what is that going to make? I mean, it's still going to be cylindrical in shape, but these cylinders are going to be totally hollow. They're going to have a very thin wall, and they're going to be these hollow cylindrical shells. So the way we handle those is different. We'll get to that in the next section. But for now, basically everything we're doing with the disc and washer method, as long as we're using this method, what the line we're rotating over is going to dictate what variable we're expressing the integral with respect to. So let's kind of recap that now. If we're rotating over a vertical line, what variable do we use? That's dy. And if we're rotating over a horizontal line, we're integrating with respect to x. So that has been consistent with everything we've done so far. So in this case, yes, I want to set this up using the variable y. So our volume integral is going to go from some bounds a to b. But still, I'm looking at outer radius squared minus inner radius squared, because I'm still looking at, pi r squared, the area of a circle, multiplied by some thickness to give us the volume of the cylinder. So now, let's figure out what those radii are. What is the outer radius in terms of y? First of all, is the outer radius going to come from the straight line, or is it going to come from curve? Comes from the straight line. The straight line is further away from x equals 1. So what is my outer radius? is it X? X minus 1. It should be Y minus 1. How come? So one thing we haven't done here is we said very early that we want to think about these things in terms of Y. So now let's re-express our functions. This one's kind of free. But if I want to re-express this one in terms of X or in terms of Y, X equals what? Cube root of Y. So outer radius, Y minus 1. What's the inner radius? Cube root of I minus 1. Any questions on why those radii are what they are? I think I need to repair something that I said before. So let's go back. Like I said, mathematically, it's not going to make a huge difference, but let's think about these two radii we defined here. We have x cubed minus 2 for the outer radius, right? For the interval we're integrating on, are we going to get negative values or positive values from that? Should get negative, right? So I'm going to throw these out. Do we have to redo this example? No. So here's the thing. This fact that we squared those values saved us, but really the way that I push this to define these, we're going to get negative radii. So I'm going to go ahead and make that. Let's repair that mistake now. So for the same reason, let's call our radii 1 minus y and 1 minus cube root y. Is it clear why I'm making that change? So to me, it feels a little bit nonsensical to talk about your radius as a negative distance. So I want to make sure we're not doing that. There are methods coming up where the squaring will not save us. So I want to make sure we're being consistent now. All right, so now that we've changed those radii, are we okay with how they're defined? So what does the integral look like from here? Volume is equal to pi times the integral from where to where?
0 to 1.
Why is it 0 to 1? It has been. I think that's coincidence in this case. They intersect at 1, 1. So I'm trying. Probably should use different numbers here. So these points are 0, 0, and 1, 1, right? So this is one of those cases where regardless of whether we're looking at x values or y values, we're going to go from 0 to 1. But what do I really care about in general? Well, yeah, so in general, I care about the intersection points, but am I integrating from 0 to 1 because I'm following the x values or because I'm following the y values? I'm following the y values. So that's what I want to be really clear about. I'm integrating over, so I'm integrating dy, which means the interval I need to set up for my bounds for my integral need to be y values. So I need to integrate from 0 to 1. And what do I integrate? So what's the inside of this integral look like?
So 1 minus y squared.
1 minus y squared first. Why does that have to come first?
Outer radius.
It's the outer radius. So basically, I want my larger volume to be positive. And then I'm subtract off the smaller volume. What would happen if I did not put these in the correct order? you get a negative value, which, yeah, if that happens, it'll tell you something about your setup. All right, so now I can, same as last time, do some simplifying. Square root of, or sorry, 1 minus y squared is 1 minus 2y plus y squared. Do I get any? Yeah, I got some cancellation. Minus 2y. That's y squared. All right, I'm gonna go stop there for a second. So you can help me find whatever errors I might have made. And for you to figure out what questions you want to ask about where this integral came from. How are we doing so far? Okay, so let's go ahead and finish it. What are the integrals of all these things? Minus y squared plus a third y cubed. Two y to the 1/3 becomes 2y to the 4/3 times 3/4, so 3/2 y to the 4/3 minus 3/5 y to the 5/3. I think all told I got 7 pi over 30. How are we doing? Shall we move on? All right, so let's get on to something different. So brand new region, brand new area, brand new line of rotation. So let's figure out what we have to do. How should we start? Draw a graph is usually a good place to start. So I got a lot of different boundaries. I think I only care about, do I only care about the first quadrant? I definitely only care about the right half, right? So the y-axis is a boundary. The line x equals 1 is a boundary. What else? Y equals x minus 1 squared plus 1. What does that look like? Should be a parabola that looks like this. What else? And the line of rotation is down here. So can I shade in the region that I'm trying to revolve? Where is that?
Space to the left of the parabola.
The space to the left of the parabola. How far downward does that extend?
Just to y equals 1.
Just to y equals 1. So to right here. How do you feel about that? How do you know it doesn't go down any further? Tells us that, so that was one of the boundaries that I did not graph, so I'll do it now. But basically it's just this little Idaho piece right here. So that's the area I want to rotate. Now that we're visualizing, hopefully that helps. So where do we go from here? So I think it's now that we've done a bunch of these, it's a good time to talk about like what are all the different questions we have to answer to set up the interval we want to set up. So what are all the different choices basically we have to make? So I don't know what our outer radius is, what our inner radius is. I think there's something even more fundamental than that we have to talk about. Right, so I sort of think that is the choice that everything else depends on, dx or dy. In this case, what is the answer to that question? It's dx. How come?
We're rotating it. Let's say horizontally.
You're rotating across a horizontal line, so you need a rectangle that when I rotate that will make discs or washers. So that is going to be dx in our case. From there, what do we have to decide? Outer radius. Now I know that in terms of x. What is the outer radius for this case? So I have a whole bunch of things that I graphed.
X minus 1 squared plus 1 minus -1.
Oof, that was a lot of stuff. Say it all again.
X minus 1 squared plus 1 minus -1.
Okay, where'd you get all that?
The first function is the farthest away.
So let me start labeling some of these. I'll call this one y1 and y2.
Y2 is the furthest line away from the line we're rotating about.
So y2, the parabola, is the furthest one away from this line, which is the axis of rotation. So our outer radius is definitely going to be defined by that parabola. Is it okay for me to call it x minus 1 squared plus 1 and not something different? Do I have to re-express it in terms of y? No, you said dx, so this is fine.
Subtracted -1 because we basically did that.
Right, basically, if we move, so the parabola is x minus 1 squared plus 1. If I were to rotate, but basically I'm moving the axis of rotation down. So it makes sense that I have to add 1 to the radius, which is essentially what subtracting -1 does. So I like that definition of the outer radius. Let's be really clear, is that going to give us positive values? It is this, in this case it will. What is the inner radius going to be? One minus -1. It's a constant, right? Does it make sense that our inner radius is just a number? if we're rotating, basically, or you're rotating a horizontal line around a horizontal line. And so it'll make a perfect cylinder. All right, so we decided we're going to do this in terms of X. We found our radii in terms of X. Now what do we have to do? What's that? The bounds. What are the bounds? First of all, are the bounds X values or Y values? I heard a lot of whispers of X. They are X values. So what's the lowest X value I care about? -1? 0. -1 is, yeah, -1's to the left of our region. And how far right am I going? 1. So those are given by my description of this area here. So I'm integrating from 0 to 1 of what? Or yeah, but wait, so what's the function I'm integrating? X minus 1 squared plus 2. All of it squared. Minus 2 squared. Dx. Would anyone feel cheated if I did this? So like I said, I believe strongly that these integrals, if you were to expand all that stuff, the integral would be a lot of polynomials, which are among the simplest things we can do. I think by far the more important and more challenging thing here is to set up the integrals. So not that I'm not going to have you complete them all the way or completely calculate them, but in terms of what I'm trying to, in terms of what I want you to learn right now, I'm hoping this is okay. But are you confident that's an integral you could do if we were to go further? Any questions before we move on? Okay. We have more? What was my thought? On the area? Oh, I have it. Okay. What should we do? Right. So that's that question first. Dy or dx? Do we have enough information to answer that question? Yes. What's the answer? Dy. Because
Rotating across a vertical line.
rotating across a vertical line, we use y. We use the vertical variable. So we're going to do dy. All right. What else do we need to figure out after that? We sure would like to know what it looks like. We know what this looks like. I must have something inaccurate here because I don't see these crossing. So let's try to scale these a little better. Actually, I know it'll help. So the way I drew it, I don't see where there's a region bounded by those curves. So maybe let's try to figure out where they cross. Can we figure out where they cross? How do we do that? I can set them equal to each other. So I get 4 radical x equals x plus 3. Where do I go from there? Square both sides. What does that do?
Factor.
Yeah, so basically I'll get rid of that square root power. So it'll be 16x equals, if I square this binomial, I should get x squared plus 6x plus 9. I got a quadratic, so what would I like to do to solve it? Yeah, move all the terms to one side. We got x squared minus 10x plus 9 equals 0. Does that factor, please? Cool. Minus 1 minus 9. All right, so x equals 1 and 9. So that helps me do this. This also tells me I'm going to diminish my scales a lot. One and 9? Am I just making this thing? Oh yeah, I'm exaggerating.
Taller.
I'm having a really hard time visualizing this. Oh, I see it now. Okay. So we'll say this is x equals 1. This is x equals 9. The area I care about's in there, right? All right. And we're going over the y-axis. All right, so have a decent visual of what this looks like. Where do we go from here? Get the bounds in terms of y. So I got the bounds in terms of x. But yeah, for the integral I want to set up, that's not going to help. So if I have x equals 1 and 9, what are the bounds of my integral actually? How'd you get 4 and 12? Why'd you plug it into that one? Did you have to plug it into that one? Okay, so that's something I wanted to make sure of, is that so to be clear, how did we find these? How did we find x equals 1, x equals 9? Set them equal to each other. So the x values agree there, but the y values better also agree there. So yeah, adding 3 to things is easier to do than square rooting things, but either one of them should give you 4 and 12. Okay, so what is the integrand? What is the function we are trying to integrate? Y minus 3 squared. Let's pause right there. Where did that come from? What's that, Maggie? Sorry?
It's furthest from the y.
It's furthest from the line. So our outer radius is going to come from the straight line. But why is it y minus 3, not x plus 3? We're integrating in terms of y. So something we did not write down, but we should now. This, if I want to re-express it as solved for x, this is x equals y minus 3. So what am I subtracting from this? Sorry, what, y over 16? How do you feel about that? Y squared over 16 squared, right? So yeah, same thing here. I want to re-express this. So y over 4 equals radical x, or y squared over 16 equals x. Question?
So why are we not accounting for the distance? of functions to line rotation?
Should we be doing that?
Like you-
Should we be, so yeah, why aren't we accounting for the distance from the line, basically from whatever our function is that gives us the outer radius to that axis rotation? Go ahead.
Because the y-axis is y or x equals 0, so there's nothing to do with that.
Right, so we didn't explicitly state it, but so what is the, let's give an equation to the line we're rotating over. In this case, y-axis is x equals 0. So let's backfill some stuff here. Or I'm just going to kind of rewrite the Washer method in some other terms here. So I'm doing a dy integral. So really what I'm doing here is I'm comparing x values. x2 squared minus x1 squared. Basically whatever those distances are. The way we've expressed before is those x2 and those x1, those are radii. But in our case, basically we're comparing, so our outer radius is a straight line. We got y minus 3. If we were going to factor in the distance to that, what would that be? That'd be y minus 3 minus 0 squared. And with the other side, it'd be y squared over 16 minus 0 squared. So no, we did not explicitly talk about what those, kind of like what those, where that axis rotation was. But in this case, since it's x equals 0, it kind of falls off.
write in distance, you just write in the equation.
Well, so all the things that we've rotated over so far have been straight lines. So you can give them as equations, but they're only going to be constants. So like we go back to this one here. So look at the way we defined this outer radius. This part right here, that right there is this function, this variable function, right? But then what do we subtract? What do we subtract from that to show where the line of rotation is? This right here. So this equation of this dashed line is y equals -1. So basically I'm comparing this y2 value to this constant line of y equals -1. So it becomes a lot more explicit when you have to think about rotating over a line that's not an axis. But in reality, we always have to pay attention to it. It's just that some of those things become simpler when the equation is either y equals 0 or x equals 0. But you're absolutely right that we always have to account for it. Good question. All right, how are we doing with this one here? What else do we have to do? Or do we have to do anything else? I'm happy with the integral. I'm happy with that being the where we end. Questions there? So we obviously don't have time to do another example, but let's talk about this. What difference did I make here, and how would you handle it? Would it be in terms of dx? I think it's still in terms of dy. How come? X equals 9 is a vertical line. It's parallel to the y-axis. But in this case, the question we just had asked, This one, you'd have to be really explicit about what those outer radii and inner radii are. Because you're not subtracting 0 from something, you're subtracting something from 9. So we'll go ahead and stop there. Yeah, I'll see you Wednesday unless you want to talk for a few minutes, but otherwise I'll see you Wednesday.